Hi there, my name is Percy. A year ago, I was invited to closely follow a Falcon 7X first sea check. This was done to conclude a field experience for the development of draftwork system Colibri. When this sea check started, we told the operator to dig into previous maintenance regarding several assets, critical assets. But time is of essence on a sea check, and quick access and traceability was lacking. In such a case, the dangers of improper maintenance and monitoring equals to more than an additional $1 million, mainly due to corrosion. Well, someone paid for it, whether or not in full knowledge of the facts. Besides the structure, the impacted assets were servo actuators, different CIC grade protection on the S duct, thrust reversers, flanges, to name a few. And each of these assets were pointed out before any intervention, and the operator duly notified. So, don't get me wrong, I'm no diviner. It's pure common sense. Predictive maintenance consists of anticipating future failures, an equipment, object, a system. Concretely, it's a question of going ahead of a failure or a malfunction, thanks to the accumulation of a set of data. Predictive maintenance makes it possible, above all, to anticipate these breakdowns and offers the possibility of intervening while avoiding a much more expensive repair. So, with predictive technology, maintenance costs are reduced by up to 40% and the number of breakdowns halved. So again, it's simple common sense. The usual types of maintenance that have been prevailing are OEM-driven, supported by most MROs, cameras, and maintenance managers, with little or no traceability, in other words, costly. Curative maintenance, also called corrective or reactive maintenance, consists in intervening on a machine or an equipment once a breakdown occurs. Preventive maintenance objective is to change the parts before a breakdown could occur. With predictive maintenance, failure is anticipated as soon as warning signs are felt. It's a main source of return on investment. Historical data are the basis of detection parameters, not excluding real-time detection, which makes it possible to intervene before any breakdown occurs. Prediction is a strategic objective. And that brings us to corrosion again. Corrosion is a dangerous and extremely costly problem. Preventing corrosion is much easier than treating it. Removing corrosion is the only sure fix once it's found. Both aircraft and people require more maintenance as they grow old. So pay attention before your aircraft becomes an organ donor with its serviceable parts going to more viable machines. Corrosion comes in many forms and cannot simply be classified as levels 1, 2, or 3. Determining the type of corrosion needs to understand the root cause and anticipate actions, thus cost saving. Anodic corrosion, intergranular corrosion, stress corrosion, fretting, exfoliation, crevice corrosion, microbiological causes of corrosion are multiple. Climate or environmental conditions under which your aircraft is maintained and operated greatly affect corrosion characteristics. So, as you can see, quite a few parameters are to be considered for a proper root analysis to prevent corrosion. The OEM publications may give general guidance on the inspection of those parts of the structure which are most likely to be attacked by corrosion. Nevertheless, in the light of operational and field experiences, other parts of the structure require special attention. Corrosion begins as the metal decays by oxidation. All metals and alloys are electrically active and have a specific electrical potential in a given chemical environment. And this potential is commonly referred to the metal's nobility. The less noble a metal is, the more easily it's going to be corroded. The constituents in an alloy also have specific electrical potentials that are generally different from each other. So, exposure of the alloy surface to a conductive, corrosive medium causes the more active metal to become anodic and the less active metal to become cathodic, thereby establishing proper conditions for corrosion. The greater the difference in electrical potential between the two metals, the greater the severity of the corrosive attack. And that brings us to those famous servo actuators, replaced on that Falcon 7X on its first sea check. Servo actuators are one of the key executing subsystems of the flight control system of your aircraft, thus an asset to greatly pay attention to. Using data from each asset in the field allows you to understand the actual operational characteristics of each asset. In a management program that focuses on analytics, data is collected from assets in the field, analyzed, and then used to optimize the delivery of maintenance. This results in earlier failure prediction, reduced failure risk and cost, and a maintenance program that is scheduled to match levels of risk. However, that data needs to be captured and analyzed for operators to benefit from it. The analysis is the key word. Without analysis, data is unhelpful. What can be measured can be mastered. What if, on this Falcon 7X first sea check, what if previous data had been analyzed from previous maintenance? What if performance was monitored? What if accessibility was maximized to apply proper CIC? What if regular checks were done to see if there were any traces of fluid leaks? What if, as mentioned previously, anything that could lead to corrosion was properly checked to avoid unnecessary costs and downtime? What I'm saying here is a proactive maintenance strategy of this kind to increase the uptime of actuators and flow control assets can lead to increased profit and enhanced safety. And it's not because of the number of hours and cycles, which was the traditional way of monitoring and maintaining. Predicting failure is the ability to intelligently and accurately predict when and on what asset, system or part maintenance should be performed. In a management program that focuses on analytics, data is collected from assets in the field, analyzed, and then used to optimize the delivery of maintenance. And that is where Colibri steps in. Colibri uses a concept of system reliability and its relationship to the reliability of its environment in an interval form. Finally, lack of proper monitoring implies weakness of negotiation with OEMs. And if I may quote one of the most brilliant minds in this century, Mr. Albert Einstein, weakness of attitude becomes weakness of character. And in the real maintenance world, it means losing cost control.